Hi there. This is a video over the questions that were submitted to me. So let's go ahead and start with this first one. It says, what is the solution to the equation log base 2 of 3x minus 4 is equal to 5? Enter your answer in the box. So when you've got something like this, when you've got log base 2 of 3x minus 4 is equal to 5, all right, this is in log form. What we want to do is we want to put this into exponential form. All right, so I'm going to take this 2 here, that's my base, and the 5 is my exponent, all right, if we were to put this into logarithmic or exponential form. So I'm going to take this 2, move it over to the other side, and I'm going to write 2 to the 5th power is then equal to 3x minus 4, and your log, that portion just goes away. All right, so now from this step to this step, you've gone from log form to exponential form. All right, so now we just want to solve this equation for x. Let's go ahead and raise 2 to the 5th power, which is going to give us 32. So we've got 3x minus 4 is equal to 32. Go ahead and add 4 to both sides, and then you end up getting that 3x is equal to 36, divide by 3, and you get x is equal to 12. All right, so there's that first question for you. All right, on this one it's saying which function g represents the exponential function f of x equals 5 to the x after a vertical stretch by a factor of 3 and a reflection across the y-axis. So one of the things that you want to think about is, let's just think of our generic formula, a times b to the x. All right, now this value here is your, we call this our initial value, but it also gives us our vertical stretch and our vertical shrink, okay? If we have a vertical stretch, that means that a, vertical stretch means that your a value has to be larger than 1. If it was a vertical shrink, okay, because sometimes you might see that, that means that a would be less than 1 but also greater than 0, so a fraction between 0 and 1. All right, so that's the first thing. Then if you reflect something across the y-axis, that means that a has to be less than 0, meaning it has to be negative. So, when we take this function here and we manipulate it, we got to put a -3. It's got to be negative, and it has to be a value of 3. It has to be greater than 1. And so our answer here is D, okay? Okay, this question is asking, it says the graph shows the function f of x equals 0.8 times 2.5 to the x power. What is the value of the inverse function f inverse at x equals 2? So when we think of the word inverse, when we're talking about inverse functions, what that means is that the first thing that comes to mind is that we switch x and y, and then we solve for y, okay? So one of the things about this question is that let's come in here and let's make a table for our function just for f of x, okay? And we're just given those points. We have the point 0, 0.8. You have the point 1, 2. You have the point 2, 5, and then you have the point 3, and then 12.5. If we're trying to find points on our inverse, then all you're going to do is you're going to switch your x and y values, all right? So then for this inverse function, you're just going to switch these. So you're going to get 0.8, 0. You're going to get the point 2, 1. You get the point 5, 2. You get the point 12.5, 3. So it says, what is the value of the inverse function when x is 2? So when x is 2, what's the value of your inverse function? And that's 1. So the answer to that question is B. This question here is correct. The way you answered it says a beehive has a population of 300. The population is increasing, okay, at a rate of 10% per year. How can you write an exponential growth function to find the daily growth rate? So here's what I think of. We have these, you have your generic equation here. Y equals A times B to the X power, okay? And so this point here, this A value, this is what we call your initial value, okay, which is your initial population of 300. Your B is your growth rate, all right? And so what we always do, if it's growth, we do, and you have this other rate of 10%. What you have is you have this. You have 1 plus your rate, okay? And your rate in this case, if you've got 10%, that would be 0.1, okay? Now, if it was decay, you would subtract these numbers, all right? And so that's how you get y equals 300 times 1.1 to the t power, all right? And that's your equation, okay? Okay, on this problem, this one's a little tricky. It says, which of the following functions has a greater average rate of change on the interval from 0 to 2 than the function that's shown in the graph? So what I would do is I would look at, there's just a couple different ways on how to do this. When it's asking you about your average rate of change, this really just means the slope between 2 points. All right, so if you wanted to calculate the slope between over the interval from 0 to 2, all right, I'm going to draw a line from 0 to 2, and I'm going to calculate that slope. And that slope is going to be, so that's from 8 up to 50. So what is that, 42? All right, so up 42 and then over 2. So your slope for this graph is going to be 42 over 2, which is going to give you 21, okay? Now, the next thing that we can do is we can calculate the slopes from 0 over the interval from 0 to 2. And how I would do that in part A, all right, I'm just going to go one at a time because I don't think A is an answer, but let's try that. What I'm going to do is I'm going to find f of 2 minus f of 0 over 2 minus 0. Now, if I'm finding f of 2, that means I'm plugging 2 into this function, all right? So f of 2 here means I'm doing 5 times 3 squared. So 3 squared gives us 9 times 5 is 45. So you get 45. If I plug in 0 into this function, I have 3 to the 0, which is 1. Anything raised to the 0 is 1. So then it's, 1 times 5 is just 5, okay? And that's your initial value. So it's actually really easy when you plug in 0 into these functions that you just get the number that's out front. That's your initial value. So 45 minus 5 over 2. So that's going to give us 40 over 2, which is 20, all right? So this slope here is not, this one's larger, okay? We're looking for something that has a larger slope. All right, so now let's take a look at part B, all right? If we wanted to find f of 2 minus f of 0 over 2 minus 0, f of 2 in this case is going to be 2 squared is 40, or 2 squared is 4, times 10 is 40. So you got 40 minus 10 over 2, which gives you 30 over 2, which gives you 15. So that one doesn't work. All right, let's try part C. Part C means you're going to do f of 2 minus f of 0 over 2 minus 0. So f of 2 means you're going to do, oh gosh, we got to do 2.5 times, I got to do the calculator, 2.5 times 2.5 times 8, which gives us 50, minus 8 all over 2. And remember, I'm getting f of 0 That's 8. That's my value right here. So 50 minus 8 gives us 42 over 2, which gives us 21. All right, so that's the same thing. So then we want to look at this last one. It's going to be D, but let's just make sure. So we've got f of 2 minus f of 0 over 2 minus 0. So if I plug in 2 into that, so 3.5 times 3.5 times 4 gives us 49 minus 4 over 2. And so 49 minus 4 gives us 45 over 2. 45 divided by 2 is going to give us 22.5. Your answer here is D. Okay? All right, on this question, it says for the function f of x equals 0.5 times 5 to the x minus 2, it says identify the y-intercept and the asymptote. Use the drop-down menus for this answer. So in this, if you've got the function f of x equals 0.5 times 5 to the x and then minus 2, what you're going to run in, let's look at just this part here. All right, this graph, if you were to graph this, here's 1, 1. Your y-intercept, your initial value is 0.5, okay? And your graph is going to look like this, okay? But then what you do is you shift everything down 2 units, okay? So this is your initial y-intercept of 0.5, but this minus 2 is going to drop everything down 2. So let's do this. Let's extend this graph down to 1, 2. So your new horizontal asymptote is at y equals 2. All right, that's your horizontal asymptote. All right, so that's going to go down here. Now your y-intercept, that point's also going to go down 2. So, if it goes down 1, that would be negative 0.5. And then if you go down another 1, so that's going down a total of 2, this would be the point 0, negative 1.5. All right, and that would be your answer. So that would be your y-intercept. Okay, on this one it says, what function is the inverse of the exponential function y equals 1.5 to the x power? Okay, so remember, inverse, when we're finding inverse functions, that means that you switch x and y and solve for y, okay? So let's do that. We've got y equals 1.5 to the x, and then let's go ahead and switch x and y. So I'm going to write x is equal to 1.5 to the y power, and then you want to solve this equation for y. Now remember that y is an exponent, and what we do to solve for an exponent is that we use a log. So I'm going to write log base 1.5 of x is equal to y, all right? And all I'm doing from here to here is I'm going from exponential to log form, and that's it, okay? And that's how you find a log function given an exponential function. So your answer here is D. All right, I hope you enjoyed these videos. Please reach out to me if you have any questions. Thanks. Bye.